Welcome back. This is the final video on the synthetic routes of aldehydes. And it's not going to be a very long video. It's going to be very quick. So we're going to look at two different ways. And I think we have learned part of it, part of this reaction in Chem 330. So we're just looking at it from a different perspective and also adding another reaction to that list. Okay, so ozonolysis. Now, if you remember ozonolysis, ozone is O3, right? There's two different ways you can get an aldehyde. One is ozonolysis of an alkene with one hydrogen on either side of the double bond. Now, the presence of hydrogen around a double bond is a must if your interest is to synthesize an aldehyde. Okay, so this is a generic reaction. Again, you do not have to remember all of it. Just remember O3 is an ozone, right? So when you see this combination, that you know ozonolysis is carried out, right? Now here's the actual reaction. Now I have highlighted the hydrogens. Now what if I don't highlight the hydrogens? Then you know that, say I did not, here I have highlighted because I'm trying to prove a point on what I wrote and want to be consistent. But on the test, I can, what if I don't highlight it? So we know that this is the two carbons containing the double bond, right? This carbon right now has 1, 2, 3 bonds, so the fourth has to be a hydrogen. This carbon has 1, 2, 3 bonds, so the fourth has to be a hydrogen. Now, doesn't matter if it's cis or trans, but what I'm trying to establish here is that this will result in two aldehyde compounds. Okay, so I do have to say this. I said I don't want to go into the mechanism, but whenever our ozonolysis is carried out, say if this is the double bond and on this side you have a bunch of carbons, on this side you have a bunch of carbons. When this goes through ozonolysis, okay, what really happens is it forms what is known as an ozonoid. Okay, this is an intermediate. So right where the double bond is, this double bond gets reactive in the process, reacts with the ozone, and results in the formation of an ozonoid. Okay. Basically, there is no double bond. The single bond is mixed with, it looks like a crown. So this is called an ozonoid, which is a stable intermediate. So intermediates in organic chemistry is typically shown inside a square bracket. So this is something you might expect on a professional exam. What's an intermediate in a ozonolysis reaction? Well, they're not asking you for the product. They're not asking you for the reactant. It's implied that the question will contain an alkene, which is a double bond. But what they're really looking for is they want to know what's the intermediate in the ozonolysis process, which is ozone, right? So the actual product itself is, if you know that both your carbon contains one hydrogen each, all you've got to do is just stop where the carbon containing the hydrogen is, draw a double bond O, leave the hydrogen be there, it's not get affected. So in this case, we're adding a double bond O here containing the hydrogen plus, and on this side, this is where the hydrogen containing carbon is, and then you add a double bond O to that as well. So basically, we have broken this up, added a double bond O to this carbon and a double bond O to this carbon, so we're ending up with a combination of aldehydes. Now, what if you have, this is rarely will be asked because this is the only compound that's this category. There's no other compound that can meet this criteria. Okay, ozonolysis of an alkene with two hydrogens on either side of the double bond is very simple, much like the earlier case. Draw the carbon containing the two hydrogens. We're basically breaking this up and adding a double bond O to that carbon. Plus, similarly on this side, see, this is the only reaction. This is the only compound for this category. So you all know that I will not probably test this because there's no surprise element to this, because this is the only compound that can do this. The top one, there's a lot of options. The bottom one, well, the point here is either you should have one hydrogen on each side or two hydrogens on each side for it to be an aldehyde. You can even have another combination, which we would look at later when we synthesize ketones. But the key here is one hydrogen on either side of the double bond, or two hydrogens on either side of the double bond. I've already said this will not probably be tested, maybe for the curiosity of seeing if you actually watched the video, I might test you, but this is really the only compound, this one right here. This is the only compound. It's unique of its kind. This is the only one that actually falls into that category, right? Well, that's pretty much the major synthetic routes that I want you to know as far as synthesizing aldehydes. I think there's one more. Hang on. No, I think that's it. This is what I want you to know as far as synthesizing aldehydes, and I'll see you back with synthetic routes for ketones, and then we will get into the reactions. All right? So stay tuned.